Okay, so let me tell you what we're doing today. Let me backtrack just a little bit. On Thursday of last week, I gave you this worksheet right here, right? And you probably did not finish it, but you probably got a lot of it done. Well, today we're going to talk about this worksheet right here, and then I won't teach the whole class period. It'll probably be about half the class. And then you will have the rest of today and all of tomorrow to finish up this one and to do the practice on this one, which is only 6 questions, okay? So what we're talking about today is using trig in a real life scenario. But before we get to the worksheet itself, I need to explain a few things to you, all right? In life, we have lines of sight. Lines of sight are like, if I'm looking directly at Edith, from here to there, that's a line of sight, right? If I look up at that vent up there, I said Edith and I meant Judith, but it's ended with a TH. I got close. So if I'm looking up at that vent up there, right? That's a line of sight. There's not a physical thing there. There's not a string connecting it, but that is a line of sight. And we can, when we do drawings, we can make those lines, right? So in real life, oftentimes we will have, like we'll use the ground as a horizontal line. Or sometimes, say maybe you've got a little person standing over here, and you can use their line of sight as a horizontal line. And maybe that little person is looking up here at a hot air balloon, right? Or maybe it's a building or a mountain, right? But for whatever reason, they're looking up there, and so that's another line of sight, right? Do y'all see? And also, this would be a line of sight going across here, this horizontal line. Y'all with me so far? So if you take like this horizontal line at the top and whatever horizontal line you're using at the bottom, and then you take that line of sight, does this look familiar to you? We've seen this before, haven't we? So you've got 2 horizontal lines, they're parallel to each other. You've got a line crossing them. Remember, we call that a transversal, right? And it creates all these angles. Well, if you're talking about a real life scenario and you're going from a horizontal line down to a transversal, that angle right there is called the angle of depression. Now, where do we use the word depression? And Okay, so where do we use the word depression in real life? Sadness. Why is it called that? Because you're feeling down. The word depression just means down, right? If you depress something, you push it down. That's what depression means. So when you're talking about an angle of depression, that means you're going from a horizontal down. Y'all with me? This, if you go from the horizontal up to make an angle, not exactly. It's called the angle of elevation because you elevate to make the angle, right? Everybody with me so far? Now, what do I know about these 2 angles? Based on where they're located, they're the same. Those are alternate interior angles, so this angle here and this angle here will be congruent. So if I tell you the angle of depression, you also know the angle of elevation and vice versa, right? So if we go, now we're going to flip over to our worksheet. If we look at this right here, now we're going to just identify angles of elevation and angles of depression in each one of these little pictures, okay? So now reminder. Angles are identified either by the letter of their vertex or by 3 letters with their vertex being in the center, right? No 2 letters. People have been telling me 2 letters today. There's no 2 letters to identify an angle. That's a segment, all right? So what would be our angle of elevation in this diagram? TSL, right here. TSL, this guy right here. That's our angle of elevation. I'm going to put an E there to stand for elevation. What would be our angle of depression? FLS. That would be this angle right here, right? That's our angle of depression. And what do we know about those two angles? They are the same. They are congruent, right? Now, if I drew a line from this helicopter straight down, do you see what that creates? It creates a right triangle. Do y'all see that right triangle right there? And so this is a right triangle that we could use if we knew numbers. We could use trig functions to solve different things for. Okay? Let's look at this one. What is our angle of depression on this photo? RTW, this guy, right? That's our angle of depression. What's our angle of elevation? SWT, this guy. And we know that those two are congruent, right? Okay, what about number 3? What is our angle of depression? DCB, right there. That's our angle of depression. Where's our angle of elevation? ABC. Now, I always do this, because just out of pure curiosity on my part. When you look at this little picture right here, what story do you think is going on in this picture? What? Actually,
What do you mean by story?
like, what do you think the story is? Like, what do you think? Santa Claus's reindeer, the deer can't get down. What do you think, Hudson?
Compared to that house and tree, that deer is really, really big.
I agree with that too. Yeah.
That's how it
So that's how you know it's magic. So when I see this picture, I always think of this as, well, this is a blind, and there's a hunter in there, and he's wanting to shoot that deer.
Yeah, I was thinking that.
Huh? Yeah, yeah. But anyway, it's just always funny to me that what we think of, what the story is on that one right there. Okay.
First I saw it, I thought it was people like that's a hundred, and then I thought it was a house.
House and Santa, that comes up a lot. Okay. What about this one? What is our angle of elevation in this picture? RPZ, that's our angle of elevation. And our angle of depression? Okay, so this is our angle of depression, and we know that they're congruent, right? Okay, have any of you ever rode a hot air balloon, just out of curiosity?
It's scary.
So I have rode in one, but not like untethered. It was tethered. I am petrified of heights, like absolutely scared to death of heights. And my husband sort of conned me into it. Well, he sort of guilted me into it, saying, you should do it because, like, when do you get a chance to get in a hot air balloon? And so I felt like I had to. It was horrible. Like, I hated every second of it. It has to do with so when you heat air, it gets lighter. And so that makes the balloon lighter because it's holding this hot air. It makes it lighter than the air that's outside of the balloon because it's cooler. And so that causes it to rise. That I cannot tell you.
It's the weight sandbags on the side.
Possibly. I don't know. I think there's a whole lot of where the wind takes you, sort of, you know. But I don't know enough about hot air balloons to really tell you. Okay. That would be an interesting ride, I think. All right. So let's take our knowledge of these angles of elevation and angles of depression and go solve some trig problems with it, okay? So we're going to kind of skip around a little bit because I don't like the order they put these in. So I'm going to pick my own order. So we're going to start with number 6, okay? Because number 6 is a pretty simple one, and they gave us a diagram to go by. We don't have to make up our own. So on number 6, they say, suppose the sun casts a shadow off a 35-foot building. All right? If you're looking at this diagram, where's the sun located?
Up there. Like the top right.
Sort of the top right, like up in this area somewhere, right? How do we know that? Because the shadow's over here. So that's just some logical thinking skills, right? You sort of have to work that out in your head, is that if the shadow is on one side, the sun has to be on the other. Let me pull this down just a little bit. Okay. It says, so this building's 35 foot tall. It says it's a 60-degree angle of elevation, so we know this is 60 degrees right here. And we're wanting to know how long the shadow is. Do y'all see that right triangle that's created? Okay, what part of that right triangle do we know? We know this side right here. How long is that? 35. Now, relative to this angle, what is that side called? It's the opposite side, right? And this side, the side we're wanting to know, how long is this shadow? It's called the adjacent side. So now we go back to our trig functions and we think to ourselves, okay, which trig function would use opposite and adjacent? And we may need to do our little jingle. So what's our little jingle? Some old hippie caught another hippie tripping on acid. So which one of those trig functions uses that opposite and that adjacent? Tripping, which stands for tangent, right? So we're going to use the tangent of 60 degrees because that's our angle measurement. Has to equal the opposite side, that's 35, over the adjacent side, and that's the side we don't know. So it gets an x, right? Now our goal here is to solve for x, but to solve for x, we've got to get it out of the denominator. We can't leave it down there. So how do we move that x out of the denominator? Multiply by the x, right? And that's going to give us x times the tangent of 60 equals 35. Now, how do we get x by itself? How do we get rid of tangent of 60? But how? What? Like what math? Right, but I mean, like what operation are we going to do? Okay, let's think this through. Here's our x. What's our x doing with tangent of 60? They are multiplied, so we're going to divide, right? So we're going to divide by the tangent of 60. Everybody see that? So over here, we divide by the tangent of 60. So on your calculator, you'll just type in 35 divided by tangent 60, right? What do you have to make sure before you do that?
You have it set to decimal or degree.
It's got to be in degree mode. If it's not in degree mode and you're using degrees, you will not get the right answer. Let's round to the nearest tenth. So what would that be? 20.2. So we now know that our shadow is 20.2 feet, right? Approximately, because we had to round it, so it's not exact. Okay, let's jump down to number 8. So on number 8, we've got this guy Kyle. And Kyle is at the end of a pier. Have y'all ever been on a pier before? You know what a pier looks like? Does everybody know? So Kyle's on the end of a pier. And it's 30 feet above the ocean. So they're showing you, here's the pier right here, right? 30 feet above the ocean. And his eye level is 3 feet above the pier. So Kyle's eye level's right here, right? Okay, so let's talk about that a second. It's possible Kyle's only 3 feet tall. If he is, what are some assumptions we might could make about Kyle?
He's a child.
He could be a child.
He's a midget.
He could be a little person, right? Would that make a difference? Maybe Kyle doesn't have legs, right? Maybe he's an amputee. Maybe he's on his knees. He could be sitting in a chair. Maybe he's sitting in a wheelchair. Maybe he's disabled, right?
What if Kyle's not even a person?
He's an animal, bro. Kyle's an animal.
It's possible. Those things are possible, except for Kyle's using binoculars. And I don't think a seagull has the capabilities of using binoculars, no matter what Finding Nemo tells you, okay?
I've been lied to my whole life.
Possible.
It's like those binoculars that you're thinking. Like, no way, like, the dog's gonna be like.
Okay, so I do really appreciate that you guys noticed immediately that Kyle was only 3 feet tall. Okay, I love that because that's the first thing I think too. Wait a minute, why is Kyle 3 feet tall? Right? Okay, now here's the thing that we know for sure. This angle is 20 degrees, which tells us, what about our triangle? This angle is 20 degrees because they're alternate interior angles, right? And that one up there is going to be 70, right? Now, how long is this side of my triangle? It's 33. The question they're asking us is if the angle of depression of the whale is 20, they gave us that, right? How far is the whale from Kyle's binoculars? So what part of this triangle are we trying to find? Hypotenuse, because they're wanting to know how far the whale is up here to Kyle. By the way, I'm super disappointed they didn't draw an actual whale here. Like, I think that just would have made the picture, but they didn't. Well, but they didn't put a person either. But I find it strange they put waves.
Wow.
Like, if everything else was straight lines, why would they put waves? I just don't understand. Yeah, they didn't draw. Well, but they put a line there. I don't know. It's just, Okay, so what is this side, this 33, relative to our angle measurement? That's right. So we're looking for a trig function that's going to use opposite and hypotenuse. Opposite because we have that. Hypotenuse because we want that. Right? It is sine. Some old hippie. Right? So sine of 20 degrees, because we know the angle measurement, is opposite 33 over hypotenuse. We don't know it. Now, our solving of this is going to be exactly like the one we just did. What are we going to do to solve it? Multiply times x, because x is in the bottom. We got to move it. Move it. Okay. Now, I am not going to bother rewriting that, y'all. Because what's our next step going to be? We're going to divide by the sine of 20. And over here, we're dividing that 33 by the sine of 20. Those x's are gone. Like, they're not there anymore. We just got 33, right? So when we plug this in our calculator, making sure our calculator is in degree mode, what do we get? 96.5. And this is in feet. So we now know that Kyle is 96.5 feet from the whale on the line of sight. That's really not very far, is it? So that's what? A third of a football field? Football field's 100 yards, right?
60 feet.
That's 300 feet.
That's 60 feet.
96.
Yeah.
Yeah, that's, no, I was talking about the thing. The, how far he is. So he's only a third of the way down a football field from this well. That's pretty dang close. Why is he using binoculars?
Those things are pretty big.
I mean, if you think about that, he doesn't even need binoculars to look at that well.
Just trying to see the barnacles on it.
Have you ever used binoculars before?
Yes. I looked at the sun.
Do you,
Joking.
weirdo? Do you? If you have never used binoculars, I urge you to take the opportunity, the first chance you get, to try to look at something through binoculars. And I actually will try to bring some so y'all can see. It's very difficult to find what you're looking for when you look through binoculars. Like you put them up and you're like, I mean, like it's there.
When you're close.
There's no point of reference. Like you can you imagine looking out at the ocean and trying to find this freaking whale? Like there's no point of reference, right? Like everything looks the same.
Blue? Oh, the water's moving. Oh, where's my...
That wave is 3 centimeters higher than the other.
Yeah. I just think it would be very difficult to do. Okay, so we're gonna do number 5 next. So on number 5, we've got this mountain biking trip going on. And so it says, on a mountain bike trip along the Gemini Bridges Trail in Moab, Utah. Do y'all know what? Well, we'll get there in a second. Nabucco stopped on the canyon floor to get a good view of the twin sandstone bridges. Now, I want to show you what those look like. So hang on just a second. Nope, wrong thing. Have you ever seen anything like this before?
Probably not.
Where it's rock formation, like this is not man-made. This is, it's like a natural arch built out of rock. You know, nobody went in there and blew out to make a hole. Well, right. So on the Moab, am I saying that right?
Moab.
In Moab, Utah, there's these two, and they're called the Gemini bridges because there's 2 of them. Gemini is the twins in astrology. I'm a Gemini. That's my astrological sign. The only reason I know that because I don't know any of the rest of them. Okay? But this person is on the canyon floor, so they're standing on the bottom and they're looking up at these bridges. That's what's happening. Can y'all visualize that in your head? So they're standing down on the bottom. By the way, is Nabucco a girl or a boy? I agree with that sentiment. I also would think it's a boy because of the O at the end. However, if you read the rest of this,
If her.
it says her. So we're going to give Nabucco a skirt. Okay, so Nabucco is standing down here at the bottom, right? And she's looking up, and up here is the bridge. Y'all with me? So she's looking up. Now it says that she's standing 60 meters from the base of the canyon. So this is 60 meters, right? And it says that the bridges are 100 meters up the canyon wall. So from here to here is 100 meters. I forgot a 0. 100 meters. Now it says if her line of sight is 5 meters above the ground. So that means her line of sight is like this, right?
I don't see how she's 5 meters tall.
I am so glad you pick up on this thing. Okay. Do you know how tall 5 meters is?
Pretty big. No,
So it's more than 15 feet. A meter stick is 39 inches. A meter stick is slightly longer than a yardstick. And a yardstick is 36 inches. A meter stick is slightly longer than that. So it's roughly, how many?
48 and 3/4 feet tall.
I don't think so.
I don't think so. No, it should be like,
It's in the
Oh wait,
teens.
never mind. I typed that wrong.
yeah, somewhere between 15 and 16, I think.
16.25.
Oh, slightly over 16. So Nabucco,
It's Slender Man.
Slender woman.
is probably not 15, 16 feet tall, right?
They're a bear. Maybe they're standing on the rock.
So this is what I'm thinking. I'm thinking that probably she's standing on a rock, right? Well, perhaps she's on stilts. I don't know how you could ride a mountain bike on stilts, but you know, maybe she carried them with her so she could get higher to see things better. I don't know. But I appreciate that we realize that 5 meters is ridiculously tall for a person, right? Okay, so this right here is 5 meters. It's from here to here, right? Do you see the triangle we have going on here? You see that this right here is 60 meters? And how tall is this right here? 95. How do we know it's 95? It's 100 total. We got to take her 5 out. Do y'all see it? That we have to take her 5 out? Okay, the question they're wanting to know is what is the angle of elevation? And the angle of elevation is going to be this angle right here. So that's our unknown angle. That's why I put a theta in there. We don't know that angle. So what sides do we have to use relative to the angle? Which one's opposite? That one's opposite. What's this one? So which trig function are we going to be using based on this information? So tangent of our unknown angle is going to be opposite 95 over adjacent 60, right? Now remember from Thursday, to find the angle measurement, what we're actually going to have to do is the inverse of tangent. So we're going to do the inverse of tangent 95 over 60. Right? So when you plug that in, what do you get? No, something's wrong. Did you do the inverse of tangent or did you just do tangent? So negative or second tangent?
I got 57.
Yeah, that should be right. Okay. It should look like this. Do you see? Okay. So what is our answer? 57.7 degrees because it's an angle measurement, right? Everybody with me? That's the whole lesson. There's actually one more question on there that we're just going to skip because it's real convoluted the way they did it. Yeah, and we may come back to number 7 and look at it, but we're not going to look at it today. So on your other side, on your 8-5 practice, mark off number 6 because number 6 is like number 7. Just don't mark all the way through it because I may pick it up like another day. Okay? So your assignment will be 1 through 7, but not 6. And then you still have to finish this worksheet. This worksheet right here has a Google Classroom assignment for it. You will take a picture of your completed work, not just answers. If you don't have work, you don't get credit. Take a picture of your completed work and turn that in. Okay? This one right here does not have a Google Classroom thing yet. It will be tomorrow before I have that one ready. Okay? Because I'm deciding how I want to do that one. Okay. So y'all have the rest of today, which is 18 minutes. And then you'll have tomorrow to do those 2 assignments, to finish up those 2 assignments. And anything else you owe me. Alrighty? I am.